Hi everyone. I'm going to tackle a problem that was given to me by one of the viewers. Yeah, it took some time for me to get to it, but I thought it was better later than never. So now let me read the question for you. So the ratio of the number of boys to the number of girls in a hall was 3 is to 2 at first. So this is a ratio problem, and you know what is the ratio at first. Then after 30 boys left the hall, the ratio became 2 is to 3. Now the ratio has changed, and if you clearly notice, 30 boys left the hall, and there's no mention of the girls, so there's no change in the number of the girls. How many boys were there in the hall at first? So simply, first let's go for to record this portion, the number of boys versus girls here, right? So say boys is to girls. Now 3 is to 2, so I'm going to say 3 for here and 2 units here, right? And this is before, and there was a change in between. So what happened is 30 boys left the hall, so minus 30 here. There is no change in here, right? So now let's say after condition. Now after this change, what happened? The ratio became 2 is to 3. Now since the number is reduced, we know that it's going to be something smaller, so I'm just going to put something like this. Let's say 2, and here it's going to be 3, right? But what we know for sure is this, that I'm going to change the color. So this here is equal in size because there was no change. Here it is represented as 2 units. Here the same thing is represented as 3 units. Now how do we make them of the same size, the units of the same size? We know that this is 2 units and this is 3 units. We are going to cut them further. So 2 and 3. What is the LCM for this? So 2 times 3 gives 6. 3 times 2 gives you 6. So here 2 times 3, meaning we are going to divide this into 3 parts. Each unit is divided into 3 parts. Here again each unit is divided into 3 parts. Now here 3 times 2. So we are going to divide this into 2 parts. Right? So now each unit here is of the same size of the unit that is here. Now we also know that if these, here we are dividing one unit into 3 parts, which also means that we can do the same thing here because the unit sizes are the same. So I'm going to divide it into 3 parts here and 3 parts here. Same here, I have divided each part into 2, so I'm going to do the same thing here, right? Oops, that's not very clear, but I think you get the point. It's totally, here you have 4 units right now. Here you have 1 2 3 4 5 6 units here. Here you have 4 units, and here let's see how many units we have. We divided each one into 3 units, so 3 times 3 gives you 9 units here, and here we have 3 plus 3 is 6 units. So it clearly shows you that there is no change in terms of numbers because there were no girls who left the place. And here there is a change. 9 units became 4 units because 30 students or 30 boys left the hall. So 9 units minus 4 unit gives you 5 units, and this 5 units represent 30 boys. So 1 unit gives you 30 divided by 5, which is 6. So 1 unit here, any of these here, because right now we have all of them of the same unit sizes. So 1 unit here in anywhere here is 6, either boys or girls. The question here says how many boys were there in the hall at first. At first there were 9 units of boys, which again means 9 units, so which is 9 times each unit is 6, 54 boys. it, my drawing could be messy, my writing could be messy, but I hope this helps you understand how to solve this problem. Remember, in this particular problem, you always look at what changes, what does not change. So if you look at here, this here boys change, whereas girls do not change. So one quantity remains the same. Oh, sorry, here. One quantity remains the same. The girls remain the same, right? So that is how we are able to establish this reference and then convert them into equal sized units and propagate that to the other side. Hope this helps. Thank you very much. If you have any comments, do let me know. I will try to reply to you as soon as possible. Thank you. Have a great day. Bye.